Hi, this is Mr. Manley. Today I want to look at evaluating a log expression that we would not be able to do except for using properties of logarithms and given some approximate values for some other logarithms. So here I've got this log base 6 of 7 over 9, which using the definition of logarithms, I don't know what power I could raise 6 to get 7 over 9. But I do have these approximate values for some other logarithms. So it should be pretty simple to see that I can use the properties of logarithms to write log base 6 of 7 minus log base 6 of 9. And that's using the property of the division property of logarithms that yields a difference. Now you can see that I know log base, or I have an approximation for log base 6 of 7, which is 1.1, and I have an approximation for log base 6 of 9, which is 1.2, and I can say that this is approximately 1.1 minus 1.2, so approximately negative 0.1. For the second one here, got log base 6 of 700. Again, I don't know what power I raised 6 to get 700. But I can operate upon this by saying that I know that log base 6 of 7 plus log base 6 of 100 is equal to log base 6 of 700. That's properties of logarithms. Again, I'm using the property which says that log base A times B is equal to log A plus log B. In that case, or in this case, I noted that 700 is 7 times 100. That's my A and B, 7 and 100. And then I was able to rewrite the log. I've got log base 6 of 7 here, matching up with this approximation there. I can make the substitution 1.1 for that, approximately. Plus, now I've got this log base 6 of 100, which I don't have here. But I notice that 100 is a multiple of 10. Noticing that, I'm going to rewrite log base 6 of 100 as log base 6 of 10 squared, and then use a property of logarithms, the power property, to rewrite that as log base 6 of 10. And now I've got log base 6 of 10. Log base 6 of 10 I've got, and I can make that substitution. And I have 1.1 plus 2.6, so this is approximately 3.7. Should always keep this all approximate because I'm just operating based off approximations. So I've run out of room here, but this is a trivial sum to do. 2.6 plus 1.1, 3.7. Okay, finally, I'm going to look at this one, and this one's a little bit tricky. And maybe you want to give it a try if you are just tuning in for the first time here, and pause and see if you can do this. It's the same log base 6 that I don't know what power to raise 6 to get 2 over 3, and the same approximations are given. Okay, if you tried that and found it, congratulations. That's a tricky little problem to work on. But if you didn't, you can go ahead and take a look here. And most of all, when we look at something like this, is not to take the specific skill and say, and learn that, but to think about this thought process that goes into this. So if I did this, log base 2 of 6, log base 6 of 3, I'm really stuck, right? And that would be my first inclination, though, based upon the previous problems and what I can do with the properties of logarithms. So I know that I've got to somehow use properties of logarithms, and I've got to somehow use the information that was given. So again, having said that, maybe you want to stop if you haven't gotten it yet and take that reminder or take that instruction that you need to use the properties of logarithms and you need to use the information given. Is there any way that we can do that? Okay, so again, coming back to this isn't getting us anywhere, right? So I'm just going to say that didn't work. Never want to completely erase or cross out the work. It's always good to leave a trail behind. Okay, so here's the big trick with this. I can see that I've got a 2 over 3 that is not useful. But how about this? What if I multiply by 3 over 3? And I'm just noticing now that I miscopied something from the previous page. I copied this log base 6 of 8 is approximately 1.2. And on the previous page, I have log base 6 of 9. Both of those are approximately 1.2. But the one that I really want to work with is the 9. So that would have tripped you up if you were, unless you'd noticed that and said, why did he have the 8 instead of the 9? So there's the 9, and they both are approximately 1.2. So that's the one I want. Okay, now back to the matter at hand. So the trick though was, look what happens when I multiply by 3 over 3. Now I get log base 6 of 6 over 9. And using the subtraction property, I get log base 6 of 6 minus log base 6 of 9. So log base 6 of 6, I know, right, by definition of a logarithm. What power do I raise 6 to get 6? Well, I raise 6 to the first power. And then log base 6 of 9, there I've got my approximation, which is 1.2. Again, I want to do approximations here. So let me go back and change this. This is actually equal. So that is equal, but now I'm going to go switch to an approximation because I'm going to use the approximate value for log base 6 of 9. So this is approximately, the 1 is exact, but now the minus 1.2, that's approximate. And whatever, 1 minus 1.2, so approximately negative 0.2. So the big trick here was that 3 over 3. And how do we come up with things like that? We just see it more often. You see it several times doing something that, taking an action that seems to be going in the opposite direction. And when you see this a few times, you start to develop a thought process that will look for that. But like I say, you don't want to just take this and go, you don't just want to keep adding the specific type of problem, but consider the way of thinking that gets us to that solution. Okay, so thanks for checking that out, and I hope that will help you on any future problems that you have, logs or otherwise.